The last set of solving one-step equations is looking at absolute value problems. An equation with an absolute value sign often has more than one solution. So for the first example, we have the absolute value of x equals 16. Remember that the absolute value takes a number and makes it positive. So if you have positive 16 in absolute value symbols, that's going to equal 16. But will also equal 16 if you have negative 16 in your absolute value symbols. So that means your x value could have equaled 16 or negative 16. For problems like this, it is okay to have more than one solution. Let's look at a more complicated problem. So the first thing we should know is that, remember, absolute value signs work like parentheses. So you want to make sure you do everything in the absolute value sign first. Unfortunately, we cannot add a and 2. So we need to find a different way to deal with this problem. We do this by splitting the problem. So we take this problem here and make it two different problems. The first problem is where we say a plus 2 is equal to positive 5, because we know that if the final quantity of a plus 2 gives you a positive 5 inside, then it will be positive and equal positive 5 on the other side. We also know that a plus 2 giving us a negative 5 would still give us this 5 on the right side. Now that we dealt with the positive and negative possible solutions, we can actually get rid of our absolute value signs, which is why all of the equations on this level don't have absolute value signs anymore. So remember, to get rid of the absolute value signs, you have to split the problem. I went ahead and wrote that statement here for you to copy. Okay, once we've split the problem, it gets a lot easier. So now you can just solve it. So remember, we want to get a by itself, so we have to get rid of this plus 2. The only way to get rid of it is to subtract 2. Plus 2 minus 2 equals 0. So that would give you just the a on the one side, but you have to do it to both sides. You always have to do it to both sides. That way the equation stays equal. And that's what our properties of addition, subtraction, multiplication, division, of equality tell us. So we have a plus 2 minus 2, which gives us just a. 5 minus 2 is 3. So that's one of our answers. Now we go to the second part of the equation. We have the same thing over here, a plus 2. To get a by itself, we subtract 2 from both sides to give us a, just a, because plus 2 minus 2 gives you 0, equals negative 5 minus 2, which will be negative 7. So now your answers are a equals 3 or a equals negative 7. Remember that it is okay to have more than one solution for problems like this. You can go ahead and test these as well, so let's go ahead and try it just to make sure that this is true, because it seems kind of funny. So we can say a plus 2, remember our first a is 3 plus 2 is equal to 5, so we get the absolute value of 5 equals 5, and the absolute value of 5 is 5, so we know that that's correct. Our next one is negative 7 plus 2 equals 5. So we have an absolute value of negative 7 plus 2, which is the absolute value of negative 5, equals 5. The absolute value of negative 5 is just 5 equals 5. So we know that's true as well. It's always important to check problems like this because they can be tricky. Pause the video now and try these problems on your own. Some of them can be kind of tricky, so if you get stuck, go ahead and turn the video back on and you can watch me do it. The first problem is pretty simple. So we just have x by itself to start, and we know that a positive or negative 3, so we can split this just like we split the other equations, or you can just do it from memory. But we know that if we split this and we have x equals positive 3, x equals negative 3, then we can get rid of our absolute value symbols. Since these already have x by itself, these are all final answers. So x equals 3 and x equals negative 3. Our next problem is 2 equals the absolute value of the quantity a minus 3. Remember that the absolute value symbols are kind of like parentheses, and we can't do that part first, so we have to split it. To split it into two problems, we start with a minus 3 equals something, a minus 3 equals something. Because it's an absolute value, we know that it doesn't matter whether or not a minus 3 is a positive value of 2 or a negative value of 2. So one of them will be positive, so a minus 3 equals positive 2, and the other will be negative, so we have a minus 3 equals negative 2. Now we add 3 to both sides to get a by itself over here. It's always the same for the other side as well, so you can add 3 to both sides and then solve down. So on the left, this one over here, we have a minus 3 plus 3 on the left side, which just gives you a. We have 2 plus 3 equals 5. So that's one of our answers. Or I'm going to anticipate that we're going to have a second one over here. A minus 3 plus 3 would be 0, so you just have a. Negative 2 plus 3 is just a positive 1. Go ahead and check your answer here. So on the right, we'll do 2 equals our first answer, 5 minus 3. That's one problem we'll check. The other is 2 equals the absolute value of 1 minus 3. So 2 equals absolute value of 5 minus 3, which is 2. 2 equals the absolute value of 2, which is 2. That's correct. Then we have 2 equals the absolute value of 1 minus 3. 1 minus 3 gives you negative 2. 2 equals, now the absolute value of negative 2 is positive 2, so 2 equals 2, and that's correct. This next problem is a little bit more complicated. So now we have two numbers in here. So since the absolute value works like parentheses, you should try to simplify as much as possible in the parentheses or the absolute value symbols as you can. So we're going to say m, and then we have plus 7 minus 2, so that would be plus 5 equals 30. Now we split the problem, so you never split it down until you figure out the simplest form of the absolute value problem, just to make it easier. And you get m plus 5 equals 30, and m plus 5 equals negative 30. M plus 5, so we want to subtract 5 from both sides. So here we get m equals 30 minus 5, which is 25. So m equals 25. And the other one, we're going to subtract 5 from both sides to get m alone. And we get m equals negative 35. So here's our two answers, m equals 25 and m equals negative 35. Go ahead and do your check real quick. I went ahead and did this check for you, so you can look at it here. You should do it on your own as well, but I didn't feel the need to make you watch me write everything out since I know you all know how to check at this point. Okay, so our last problem says negative 2 equals absolute value of x. So pause your video if you haven't already done this one on your own and give it a try. This one is definitely tricky. So for this problem, we would be splitting it and saying x equals negative 2 and x equals positive 2. But this is already a negative, and an absolute value can never equal a negative. So if you were to go and test these answers, you would say absolute value of negative 2 equals 2. Oh, is negative 2, and the absolute value of 2 equals negative 2. So here, this one you'd find that absolute value of negative 2 equals positive 2, which is then equal to the right side, which is negative 2. That's not true. And then the absolute value of 2 is 2, which equals negative 2, which is also not true. So these are not solutions to the problem. You can never have an absolute value sign around the entire side, so you can't have a number with an absolute value equal a negative. So be careful of that because that's a trick you may see in the future.